Today we're working on equations with fractional or negative exponents. Equations with fractional negative exponents, the way to solve is as follows. You're going to isolate the expression containing the exponent. So basically, your variable has an exponent attached to it, and you need to get the variable by itself. So if you isolate it, then raise both sides to the reciprocal of the power, you should be able to then solve the resulting equation and check your answer in the original. Now, why do we raise it to the reciprocal power? Well, let's take a look at something up here that I can show you. If I had x raised to the 2/3 power, and I raise it to the reciprocal of that power, so if I raise it to the 3/2 power, I've got what's going on here, which is called power to a power. So I'm actually multiplying the exponents, so I would end up with x to the 6/6 power, and 6 over 6 is x to the first power, which is plain old what? X, you're right. So basically, by raising it to the reciprocal power, the exponent becomes a 1, which means basically you have the base. Okay, recall, to solve radical equations, we isolate the radical and then we squared both sides of the equation. This is the same procedure because a radical can be rewritten as an exponent of 1/2, and the reciprocal of 1/2 is 2, and I just showed you what happens when you multiply by reciprocals. All right, so let's take a look at number 1. I'm going to go nice and slow. First thing is I have to isolate the expression with the exponent, so I need to get x to the 2/3 by itself. So what I'm going to do is add 1 to both sides, and I have x to the 2/3 power equals 25. So now I'm going to raise both sides to the 3/2 power. On the left, I get x to the 6/6, which actually is x to the first, which is plain old x. And on the right, I just put it in my calculator. 25 raised to the 3/2 power, and I end up with 125. And then I have to check it. So right now, take your calculators out, go 125 raised to the 2/3 power, minus 1, enter, and see if you get 125. I'm sorry, see if you get 24. And if you do, it checks, and it should check. All right, let's take a look at number 2. I'm going to actually get the y to the 3/2 power by itself. So I'm going to actually divide each side by 3. And I'm going to end up with y to the 3/2 power equals 64. Since I isolated the base and the exponent, I'm now going to raise both sides to the 2/3 power. So I'll end up with y to the first, which is y on the left, and 64 to the 2/3 power on the calculator is 16. So again, I need to plug it back in to make sure it works, and just to save a little time, I'm going to tell you it works. Let's skip number 3 and move down to number 4. With number 4, we have an actual binomial that's being raised to the 5/2 power. So basically, the binomial and the exponent is already isolated. So right now I'm going to actually, sorry about that. I'm actually going to raise both sides to the 2/5 power because my base is a binomial and it's already isolated. So I'll end up with y plus 3 to the 10/10, which is y plus 3 to the first, which is plain old y plus 3. And 32 raised to the 2/5 power on the calculator is 4. Continue solving. I'm going to subtract 3 on both sides. Y happens to come out to be 1. So I'm actually going to plug this guy in the calculator to see if it works. So 1 plus 3 is 4. 4 raised to the 5/2 power, enter. You're right, it's 32. So it checks. All right, let's take a look at, now let's go back to number 3. I'm going to actually isolate the x to the negative 1/3 power by dividing both sides by 2. So I have x to the negative 1/3 power, which equals 3. Now again, I'm solving, and my base is an x. So I'm not going to actually apply the negative exponent rule here, because when I actually raise x to the negative 1/3 to its reciprocal, I'm not changing its value. I'm just reciprocating the exponent. So I'm actually raising it to the negative 3/1. And I have to do that to both sides, which really is raising it to the negative 3rd power. And when I multiply power to a power rule here, a negative times a negative is a positive. You're right. So it comes out to be plain old x. So again, you don't want to eliminate the negative exponent when you're solving, because if you raise it to its reciprocal, you're actually going to turn it into a positive, because a negative times a negative is a positive. On the calculator then, you can put 3 raised to the negative third power and end up with a decimal and go math fraction enter, and you're right, 1/27 is the answer. And again, we'd have to plug it in to check it, but to save time I will tell you it works. Okay, let's move on to another on the next page. This one's a bigger problem. It looks like it has multiple steps for me to actually get the base and the exponent isolated. Now again, look at my base. My base is a binomial. So we're going to go one step at a time. First thing I'm going to do is I'm going to add 4 to both sides. Again, I'm trying to isolate the base and the exponent. Then I'm going to divide each side by 2. Which is 27 here. Now I actually have the base and the exponent isolated, so now I'm going to raise both sides to the 5/3 power. And end up with 3y minus 4 to the first power, which is 3y minus 4, equals 27 raised to the 5/3 power on the calculator is 243. I'm going to now continue to solve by adding 4 to both sides. So I get 3y equals 247. I'm going to divide each side by 3. I end up with a very long decimal. So I end up with y equals 247/3. I'm going to have to plug it back into the original to make sure it works. And I'm going to give you a little bit of time. I want you to pause the video, put in your calculator, and double check that this works. Be very careful by placing your fraction in parentheses and also the other parentheses. Okay, hopefully you put it in your calculator and you ended up with 50 just like I did. So y equals 247/3 is actually my answer. Okay, that'll do it for today, but before you actually put your notes away, I want you to do number 6 on your own and see how well you do with a little bit of practice, and then bring it into class tomorrow, and that'll be the first thing we go over. And if you have any other questions, please bring those also to class tomorrow, and I will answer them so that you have everything cleared up. See you tomorrow.